Let's go over your test number 7. So the first question says polymers of silicon, oxygen, and carbon are carbon or hydrogen. So these all come together to form what? Okay, does it form silicone? Does it form silicates? Does it form silicarbonates? Or does it form silica? So let's go thinking. Well, for one thing, we have silicon and oxygen, which would be a silicate, but we also have carbon. So the one that has all three in them would be a silicone. Silicone has silicon, oxygen, and carbon. The others, basically, well, there's no such thing as silicarbonates. And silica only has oxygen and silicon in it. So it would have to be silicone, the first one. So number 2, a mineral components containing metals and silicon, oxygen. So mineral components are containing metals and silicon, oxygen. So anytime you have oxygen, you think of ATE at the end. So anyway, so we have silicone. Silicone, of course, has carbon in it, which we already went over. B is silicates, or is it silicarbonate, or is it silica? So whenever you need have oxygen to it, you're going to think it's a silicate, right? B. These are of course, you can look these up in your book. Number 3, Epsom salts are hydrates of what? And these are baths to reduce swelling when you put Epsom salts in your bath. So are they magnesium hydroxide? Are they a magnesium carbonate? Are they magnesium sulfate? Or they're magnesium oxide? Well, I kind of had a heart because I knew they were magnesium. But I know that magnesium oxide produces bricks, so it can't be that one. And magnesium hydrogen, I don't think so. That would be a different type of things. But sulfate, when you take a bath sometimes, the sulfates actually soften. So I would say it's C, magnesium sulfate. You can actually look Epsom salts out and see what's in them. So on to number 4. Milk of magnesia is a suspension of what used for stomach acid or laxatives. So have you ever taken milk of magnesia? Well, what is it? This is another one. We know it's magnesium, but is it magnesium hydroxide? Is it magnesium carbonate? Is it magnesium sulfate? Or is it magnesium oxygen? Well, we know what magnesium sulfate we thought was Epsom salt, so it can't be that one, and it can't be a magnesium oxide. We know those are strong bricks. So which one? Well, we find out it is magnesium hydroxide, which is A. Number 5, an expensive metal widely used for automotive catalytic converters and spark plugs and surgical tools. So this is a metal. Is it A, platinum? Is it B, silver? Is it C, carbon? Or is it technetium? Never heard that one, huh? So which one would it be? Well, of course, if you look at it can't be carbon or silver, then we know it's going to be platinum. And platinum is what they use in catalytic converters. A. The nonmetal that exists in rhombic, monoclinic, and plastic forms depending on the temperature. So which one is this? Is it sulfur, phosphorus, carbon, or boron? So basically, as you look at sulfur, it comes in that rhombic form. As you actually look in your book, and you'll see the different form for sulfur and the monoclinics and onto plastic forms at high temperature. It changes form. Remember they showed it in the solid form, and then they melt it into this melty goo, and then you put the goo in the water, and then it turns into like a plastic thing. This is sulfur. And sulfur kind of has that smell, that pungent smell. So 7, a lightweight metal extracted from bauxite widely used for aircraft, spacecraft, and beverage cans. So what do we have? Like a can of Coke, what is it made of? Aluminum, magnesium, beryllium, or titanium. Aluminum cans, right? Aluminum. So, A. Number 8. Most of the element what is produced annually and is used for acid production. So, of course, a country is actually, is any country that produces a lot of this acid is considered an industrial country. And so what kind of acid is this? Is it sulfuric acid? Is it nitrogen acid? Is it phosphoric acid? Is it hydrogen or ammonia? Well, let's think of which one it is. Which one do you think it is? Right, sulfuric acid, sulfur. So, and that's one of the questions that we went over. So, number 9, steel is an alloy of iron and a small percentage of what? Carbon, copper, oxygen, or manganese. So, when you take iron, you put it with what? Coke. And what is coke? Coke is carbon. So, the answer would be carbon. A. So number 10, gold and silver are typically extracted from low-grade ores using which method? So now we're not talking about iron. So blast furnaces would be iron, right? So it can't be A. The B is a cyanide process, C is electric arc, and D is basic oxygen. Well, we know that blast furnace is iron, basic oxygen is producing steel, electric arc is producing steel. But what about cyanide? Yeah, it would be cyanide. In fact, a lot of times when they're mining gold and silver ores, they use cyanide, and this cyanide goes in to the water and such. So we have to be very careful, especially living in gold country, that we do not get cyanide, right? Because they use this cyanide process of changing or getting gold and silver out of their ores. Let's just say that. Number 11, laughing gas. Laughing gas is a compound used for anesthetics in minor dental surgery. So if you go into surgery to have your wisdom tooth, they may give you laughing gas. Well, which one of these is laughing gas? Is it nitrous oxide? Is it B, nitric acid? Is it nitrogen oxide? Is it ammonia? Which one did they give you? Yeah, you're right. It's nitrous oxide, A. Number 12. The element what is typically extracted from petroleum and natural gas using the Claus process. So which element uses the Claus process? Well, we know it's not iron because we went through iron, and we know it's not hydrogen, uses another kind of process. So let's look. Is it hydrogen? Is it sulfur? Is it carbon or nitrogen? Which one would you see the Claus process, if you remember? The Claus process happens to be sulfur, right? Sulfur, if you look in your book. Number 13, brass and bronze are alloys of what? A, zinc, B, tin, C, lead, or D, copper. Well, they're both alloys of one of these. And so basically brass being copper and zinc, and bronze being copper and tin. So they'd be alloys of copper, right? So even though they have a little mixture of zinc and a little mixture of tin, we would call them alloys of copper. Number 14, the process by which certain microorganisms convert atmospheric nitrogen to a form that can be used by plants. So what happens? Remember this with this basically bacteria, these bacteria fixing. And what do they do? They have, is it called nitrogen fixation? Is it called photosynthesis? No, photosynthesis is basically, taking light and carbon dioxide and turning it into oxygen and food, right? So it can't be photosynthesis. And lightning does put nitrogen into the ground, but it's not nitrogen fixation, or fixing it. So which one would it be? I would say nitrogen fixation. That's what these bacteria do. They fix nitrogen into the soil by attaching to some of the legumes and beans to their roots. Nitrogen fixation. Number 15. The blast furnace is used to extract what from its ore? Blast furnace, is it aluminum, iron, copper, or gold? Blast furnace is always iron. It's taking iron out of its ore and bringing it into the state of pig iron or cast iron. So, iron. Number 16. The hormone thyroxide is produced by the thyroid gland, and it contains what? Does it contain iodine, bromine, chlorine, or fluorine? Of course, we know iodine is very important for the thyroid gland. If you don't have enough, you can have thyroid problems and have a goiter, a big, tumor-looking thing on your throat, right? Which is a benign growth of the thyroid gland. So, on to number 17. Deposits inside boilers and hot water heaters and teapots are often due to what? What are these deposits made of? When you see this kind of a scale, they call them scaling, so you have to descale things. So what are they made of? Are they made of CaCO3, which is calcium carbonate? Are they made of CaSO4, as calcium sulfate? Are they sodium Na2CO4, which is sodium carbonate? And D is sodium sulfate. Well, they're not sodium, because it's not salt that's making these. And sodium chloride is salt, so it can't be C or D. So it's calcium, but we have to know, is it calcium carbonate or is it calcium sulfate? Is it A or B? And it's calcium carbonate. Calcium sulfate would produce more of a sulfur. So these scaly deposits are calcium carbonate, which is A. Number 18. Most helium is extracted from what? Helium is a gas. So the first says A, helium bearing ores. Helium doesn't come in the ground in the ore. So it can't be that. Is it petroleum? Petroleum is like liquid, and helium doesn't come in a liquid. Is it C, natural gas? It is a gas. And so is it D, power plant exhaust? No. Helium comes from natural gas. In fact, that's how we have to get it, from natural gas. So on to number 19. What group of elements are found in nature only as free, uncombined elements? So if you go through your elemental table of all of our elements, you'll look clear to the right and you'll see a column that's called noble gases. And these gases are unreactive. They don't like to react with any other substances because they have full electrons, actually. Now, some of them they've got to react in a laboratory, but mostly they do not react. And these are called noble gases. So you can write in noble gases. Number 20, what is the third most abundant element in the Earth's crust? So what is the most abundant in the Earth's crust? Oxygen, right? And the second is silicon. And silicon is a semi-metal and oxygen is a non-metal. So the most common metal, or the third most common element, is what? Aluminum. Can you believe that? It's aluminum. Number 21. Which class of nonmetals is the most reactive? So if you go through your nonmetals and you go clear over to basically to the right side, and not the noble gases because they are full. It's the next one. It's column 17, and these are very reactive, and they're called halogens. And the halogens have things in like chlorine and fluorine. Those kind are very, very reactive, and these are the most reactive would be the halogens. Number 22. What compound is used in fertilizer manufacturing? Is produced by what process? By the Haber process. Remember I told you the Haber process? The Haber process has a H in, so it's like it has hydrogen and what? Nitrogen. And what do hydrogen and nitrogen produce? Ammonia, right? And the basic the basic production of hydrogen and producing something out of hydrogen is ammonia. And so ammonia, it's basically NH4. That's nitrogen and hydrogen. 4 hydrogens to 1 nitrogen, NH4, or ammonia. You can write in ammonia. Number 23. What alkaline earth metal is essential component of bone and teeth? What do you need for your bones and teeth? What element, what alkaline earth element would help you make your bones and teeth strong? I hope you knew calcium. Calcium is that as alkaline earth metal in column 2. So calcium is very important. On to the matching. Let's go over the matching. Number 24. And these are pretty easy because just look in your periodic table. In fact, you can stop the video now and get out your periodic table. So which column, which matching point, as you look in the columns, has fluorine, chlorine, bromine, and iodine? So you've looked that up, it's in column 17. And what do you call those? And they're very reactive. They're called halogens, D-halogens. Number 25, which column has, includes platinum, silver, and gold? Think of silver and gold, and you look in your column, silver and gold and platinum, what would you say? I would say they're very precious metals. So G, precious metals. Number 26, you have boron, silicon, and germanium. The clue there is silicon. So what is silicon? Silicon is what they used in like computer chips and stuff, and it's not really a metal, but it's a semi-metal. So that would be H, semi-metals. Number 27, this includes helium, argon, krypton, and xenon. So what are these? They come clear on the right in the periodic table. And what are they called? They don't react hardly at all. In fact, helium you can't even make helium react. And I don't think you can make argon or react either. Or there's a couple of them they can do in the laboratory. But anyway, what do you call these? Noble gases, E. Number 28. What includes beryllium, magnesium, calcium, and barium? So they're like in column 2. And so what do we call these? Well, they're not alkali metals because alkali metals are sodium and potassium, but they're alkaline earth metals. So B. Number 29, which includes palladium, rhodium, iridium, and osmilium. So they're very weird, but as these weird metals come together, they are in a certain group, and this group is called the platinum group metals, where platinum is in that group too. They're similar to platinum, and so F. So number 30, lithium, sodium, potassium, and cesium. What are they? They're in that first column, and so what do you call them? The alkali metals. Not the alkali earth metals, but the alkali metals, which are A. So that one wasn't too hard, especially if you have your periodic table in front of you. So let's go on to the completion questions. And so completion questions start. Hematite, Hematite, is the most common ore of the element of what? Hematite, and we had that before. What is it? Right, iron. Hematite is a type of iron. In fact, it's the most common iron. Number 32, borax is one of the most common compounds of the element what? That's pretty easy. Borax and boron. So it's the element boron. Number 33, the Hall-Héroult process is used to produce what? So the Hall, remember this metal, actually it's a metal, this metal was very hard to get out of the ore. Even though it's so abundant in the earth, they had a hard time because they had to do it at such high temperatures. And so Hall and Héroult put together a process of bringing another element into the process so they could basically make the process a lot easier at a lower rate. And so this process now, bringing in, I think it's cryopyrite, or I can't remember the exact name, I'm pronouncing it wrong. But anyway, bringing this into producing what? Aluminum. Aluminum is so much, it's all over in the crust, but they had to get it out, and now they can do it by doing this process that they put together to get the aluminum out of the ore. Bauxite. Bauxite is a type of aluminum. So on to number 34. Two or more forms of the same element that differ in their properties but exist in the same physical state are called what? Allotropes. Remember we talked about that? You have an allotrope of, I always think of oxygen and ozone are allotropes. They're different forms even though they're the same element. Okay? Allotropes. Allotropes. 35. Lye and caustic soda are common names for what? So think of soda. So think of sodium, right? So sodium what? So they're common for sodium hydroxide, right? Number 36. Water containing high concentrations of calcium, magnesium, and iron. So if you have a lot of calcium and magnesium, like we did when we lived up in Colfax, we had a lot of magnesium. And what we had to do, we had to get a water softener because they made hard water. So they're called hard water. That's your answer. Number 37, malachite, cuprite, and chalcopyrite are what? The key right there is cuprite with the Cu, because the symbol of Cu means what? Copper. Copper is your answer. So number 38, ozone is the allotrope of the element what? Ozone is what element? Oxygen, right? It's just an allotrope of oxygen. So let's go on to the multiple choice here. Number 39. What naturally produced noble gas can diffuse into home basements and is associated with an increased risk of cancer? So this is going to be like a radioactive type. So is it A, helium? Is it B, radon? Is it C, argon? Or is it D, neon? When I look at that, which one is more radioactive? Of course, radon. It even sounds like radioactive, doesn't it? So radon. What is the most reactive of all the elements? Which one is the most reactive? In fact, you can't even find it in its normal state, only as an ion. And some of them are like that, but this is the most reactive. Is it nitrogen, oxygen, chlorine, or fluorine? Fluorine is the most reactive of all the elements. Fluorine. Think of fluoride in your teeth or so. Number 41. What element is produced industrially by steam reforming? Think of steam, and steam is water, H2O. So which element would you want to be getting out? Well, it's either going to be hydrogen or oxygen, but it's basically not, oxygen. So anyway, steam reforming is always hydrogen. So it's not, A is carbon, B is oxygen, C is hydrogen, and sulfur is D, so C. What semiconductor is the most commonly used to make computer chips? Which one? Is it germanium? Is it boron? Is it cadmium? Or is it silicon? What are computer chips made? I hope you know they're made of silicon. Which of the following statements best explains why sulfuric acid can be used to measure the health of a United States economy? A, sulfuric acid is used extensively in industry. B, sulfuric acid is dangerous. C, about 40 million tons of sulfuric acid produced annually. D, sulfuric acid can dehydrate compounds containing hydrogen and oxygen in a 2-to-1 ratio. All of these are pretty true, but which one would make us an industrial nation? Well, industry is the key, so I would pick A. Sulfuric acid is expensive in industry, so that would make us an industrial nation, right? I guess. So I'm going to probably stop and do another video because we have quite a few more questions. So let's take a break and I'll go to the next video and finish up test 7.